Alright, in this video we're going to do a quick discussion of how to work through the calculations for the extraction of KOH in wood ash. I am not going to plug in all the numbers, and I made up these titration numbers. They are probably nothing like what your numbers are. I want you to use your numbers. Okay, so here's the general idea. So I measured out my ashes. I have no idea what your numbers were. I just made up a number here. Total volume of the solution when you poured it back into the tall graduated cylinder, let's say it was 115 milliliters. I divided it by 1,000 to get 0.115 liters. These, you should just have these numbers. These are what you experimentally measured. Your values are supposed to be between 0.07 and 0.08. I picked a number slightly outside of that range, but it doesn't really matter for this. Okay, you have your initial volume of your KOH that was in the burette, okay, to 2 decimal places. And then you titrated it until it turned that light pink color, and then you measured the final volume. The difference between those numbers is the volume of the base used. So if you take 17.56 minus 11.14, which were my made up numbers, I got this number. Your number might be like 2 point something or 6 point something or 17 point something. I have no idea what your numbers are. Okay. And then my final value for this, for the first run, is my initial value for the second one. And then it went up and I used it. I did a second titration and I got a value of 6.18. Great. Okay. The next thing it asks you to do is to calculate grams of KOH per gram of ash. Okay. So what you're going to do, is you're going to start with your mass of KHP. So it's 0.086, which was my made up number. I don't know what your number was. And then it says to use the molar mass. Okay, you could add up a potassium, a hydrogen, 8 carbons, 4 hydrogens, and 4 oxygens, or you can realize that the lab gives you the number. It's 204.22. So 204.22 grams per mole. You're dividing by this so that grams cancel out, and that will convert from grams to moles. The balanced equation that you were given on the front page shows that for every 1 mole of KOH, you will have 1 mole of, this is KHP. So it's a 1-to-1 ratio. So if we plug this all in, we will get moles of KOH. It's probably going to be a small number because we're taking 0.086 divided by 204.22. Okay? And then times 1 divided by 1 doesn't change anything. So the number I got here was 4.21 times 10 to the negative 4th. Honestly, probably only get 2 sig figs on this, but that's okay. Okay. We can solve for the concentration of the solution, the molarity, by plugging in this new number. So I didn't leave myself space, but I'll just write it in here anyway. 4.21 times 10 to the negative 4th moles of KOH divided by the volume in liters. My volume is in milliliters. It was the difference, the amount used, the difference between the volumes in the burette, the amount used total. I converted it to liters by dividing by 1,000. So I'm going to take this number that I had just calculated, divided by the volume, which is 0.00642. Okay, and I got 0.06559, blah, blah, blah. Okay. Again, probably only 2 sig figs anyway. Okay, that tells us the concentration of the solution, and I guarantee your number's probably not going to be anywhere near this because I just made up this volume at the bottom, and my number is outside of the range of expected numbers, and that's fine. Okay. It asks you to solve for grams of KOH. Okay. So since we know the concentration of the solution and we know the total volume of the solution, we can figure out how many moles that is, and then we can use the periodic table to convert from moles to grams. So my total volume was 0.115 liters. I have no idea what your number is. Please don't use 0.115 unless that is what your number is. And then we're going to take this number and plug it in here. This is moles per liter, and since this is liters, this will cancel out to give us moles. So we plug that in. Only 2 sig figs, but I'm writing it all in there. And then this first part would cancel out to give us moles. Okay, so this part would give us moles of KOH. and it wants grams, so we use the periodic table to convert from grams to moles. If you add up a potassium, an oxygen, and a hydrogen, you get 56.105. So we're going to take this number times 0.115 times 56.105. And I got 0.4232. Oops. I can't write numbers. Sorry. 4232 grams of KOH. That is the total amount of KOH that was extracted out of my fictional amount of ash. Okay? It wants to know how many grams of KOH there were per gram of ash. So that's how many grams of KOH I had total. To get the ratio, we need to take the 0.4232 grams of KOH that I just calculated, divided by how many grams of ash I used total, which my fictional number was 53.72. I don't know what your number was. Okay, 53.72. And so it's going to be a very small number, and that's fine. Okay? What this means is that per gram of ash, there was only 0.0079 grams of KOH per gram of ash, which is a very small number, but that's okay. Okay, so this is the kind of overall walkthrough, and you would do this twice, once for each titration. So you two different starting masses and then two corresponding titrations. You would have to do all this calculation twice, and then you would average the two. Okay, and that on average will tell you how many grams of KOH you should get per gram of ash. Okay, your grams of ash will be the same for both, but everything else you'll have to do twice. And then there's some information here about, 1 gram of biodiesel requires 4 grams of KOH. How many grams of ashes would that take? And then it's asking about, is this a feasible source for KOH? These are the type of things that you need to analyze to work through your lab report. Okay. As far as the calculations, if you have any questions, let me know. I have office hours, or you can send me emails. I did this kind of on the fly. Hopefully I didn't mess it up, but let me know if you have questions. Thanks.